Okay, we're looking at example 512, and we're supposed to locate the center of gravity of this steel machine element shown. And it gives us the information about this. Okay, I am going to just do this purely in Excel. There's stuff that would probably be nice to be able to write down a little bit easier than it's going to be to show you on this, but I think that the bulk of this is going to be a lot easier here doing this in Excel. So let's march forward and do it in Excel. So what we're going to do is we have this body, and we're going to break it into individual elements. Now these two elements, you'll notice I'm going to subtract off those things. Now you'll notice in previous examples I've just done 2 times something. In this case, that's not the case because this hole has a different effect than this hole with respect to the z-axis. With respect to the y-axis, it's the same. With respect to the x-axis, they're both lined up, but in the z-axis, they're different, right? And you can imagine if you were to cut a hole further out here, it's going to have more effect than if you cut it out close in. So I'm going to have 2 separate ones. I'm going to have this rectangle, and I'm going to have this semicircle. So let me just talk about this real quick. You could see I could draw this line up through here, right? And then have a semicircle plus a little segment. That would just be unnecessarily complicated. Semicircles we know we have kind of information on, if you will, like nice and easy. So we're going to draw a line this way through here, and we're going to have this semicircle and then this rectangle. And we're going to label the rectangle part 1, this semicircle part 2, and then this one part 3, and this one part 4. Okay, so let's fill it out. The volume. What is the volume of the rectangle? Well, it's the surface area times the thickness, right? So the area is going to be 4.5 times this distance, which is, this radius is 2, so this is going to be times 2, and then times this thickness, which is times 0.5. So there is, I guess I could have figured that one out. That's the volume of this one, right? So what is the x bar of a nice easy rectangle? Well, x bar, remember, this is the x-axis right here. So where's the centroid of this? Well, it's halfway through here. So that is 0.25. What is the y bar of this rectangle? Well, if this is 2, it's going to be halfway, and it's going to be minus 1, right? Everyone goes with minus 1 because it's in the negative y direction. And then what is the z bar of this thing? Well, it's 4.5, so it's going to be 4.5 divided by 2, which is 2.25. Okay. Now this one is the reason this is why I'm doing it in Excel. X bar times volume. Oops, times volume. This one is going to be y bar times volume, and this last one is going to be z bar times volume. Boom. Okay. Let's look at body 2. Here we go, body 2. We have a half circle cut out. Okay, so what is the volume of that? Well, it's the area times the thickness. Well, the thickness is 0.5, 0.5. And what is the area? It's 1/4 pi r squared, right? So pi times 2 squared divided by 4. What do I do? I need to make that an equation because this is Excel. Boom. Okay. So there's the volume. Now, what is x bar? So it's the direction of this. Well, we know for a half circle, it's a 4r over 3 pi, right? So we have 4r over 3 pi. But remember, this is from right there. So this x bar needs to be 0.5 plus 4 times r, which is 2, divided by 3 times pi. And again, need to make an equation. That is our x bar. What about our y bar? Well, our y bar is in this direction, so it's going to be minus, and it's again 4r over 3 pi, but this time it's flush with that thing, so we don't actually have to offset it by the 0.5. So minus 4 times r, which is 2, divided by parentheses 3 times pi. Okay, z bar. What is our z bar? Well, that's nice and easy. It's just a uniform thickness, so the z bar is simply 0.25. Okay, and then I'm going to do this again where I'm just going to copy all these down. Okay, and we get some fun formatting that I'm not going to mess with here. Okay, body 3. So which one is body 3? Let's call, to be consistent with the book, we'll call this one body 3 and this one body 4. Okay, so what is the volume of body 3? Well, we're talking a circular disc with a diameter of 1, so it's going to be pi times is the area times r, which is going to be 0.5, right? Squared is the area times the thickness times 0.5. But this is going to be a negative value because we're subtracting it off. Okay, and for the record, we can just go ahead and copy that into here. Yeah, we'll deal with that later. What is x bar? X bar is going to be, again, 0.25. It's in the middle of that. Y bar, so how far down? Well, this is 2 from here to here. The diameter is 1, so it's going to end up being minus 1 is going to be y bar. And what is z bar? It's the distance from here to this centroid here. So we kind of have to do this backwards. So it's 3 inches from here to there. Oh, I messed up. I'm sorry. We're working on this one. So it's 4.5 inches to here, and then an inch back in there from there. So z bar is 3.5. And then these things should take care of themselves because that's why we're using Excel. Now this last one, I'm going to just copy this straight down into here because it's the same volume. The x bar is going to be the same, right? The y bar of this one is going to be the same again. But the z bar, now instead of, we want to go from here, from this axis to this point right here. So it's 4.5 to here, minus 1, minus 2. So 4.5 minus 3, which is 1.5. And there we go. So now let's take the sum of these numbers. That's what the sum column is about. I can do the same thing again where I just drag it over here, and then for clarity's sake I can get rid of those so no one thinks that there's anything there that we're trying to use. And we have our first moments with respect to x, y, and now z. But we don't care because that's not what's important. What do we actually care about? We actually want to know what is our x bar, y bar, z bar. And it comes down to the x bar times sum of area, right, is equal to the sum of x bar times area. Okay, so you can divide through by the sum of the area and get that. So let's just do that right here. So x bar is equal to, and we'll put it right here. It's the sum of the x bar times area. Well, hey, look, we have that one right here. That. Okay, so this is equal to that divided by the sum of the area. Hey, look at that. We have that right there. Boom. And we have our x bar. Our y bar is equal to the same thing, right? It's equal to the y. It's equal to that divided by that. And lastly, our z bar is equal to the same thing. Yet again, it says it's equal to the z bar times volume divided by the sum of the volume. And that is our answer. That is so much easier to do in Excel than doing it by hand. And so there you go. Look at this. I'll even make it nice and bright so you can see it. That is our answer. Which means that, so our x bar is 0.57, so it's a little bit out here in empty space. Y bar is minus 0.9, so it's not quite halfway down. It's kind of somewhere up here. And the z bar is 1.6, so the centroid is kind of here-ish. And there you go.